Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is normal distribution, one of the most important distribution that we have. So a normal distribution is a bell-shaped curve characterized by two parameters, mean and standard deviation. So here, three normal distribution. Properties, symmetric, the top, the same distance to the left and to the right. Mean is equal to median and mode. Range of x is unbounded, so it never touches the the x axis. And empirical rules apply. So we see it a lot in real life. So properties. There are an infinite number of normal curves. Each normal curve is different from one another. The highest point is over the mean, also the median and mode. The curve is symmetrical about its means. Left and right are mirror images of each other. The tail of the normal extends to infinity on both directions. The tail gets closer to the horizontal axis but never touch it. And the area under the normal curve is to the right of the mean equals the area to the left. And the area under each half is 0.5. So here, two normal curves with different means and equal standard deviation, they will only go to the left and to the right. And two normal curves with different means. So here we have the same, but different standard deviation. One will be narrow, the other one will be wider. And here, the normal probabilities. So on this area, the probability that x will attain a value between a and b. And three important percentages. Average minus 1 standard deviation and median plus 1 standard deviation, 2/3% of the numbers will be on that area. 95% will be on the range. Mean minus 2 standard deviation, mean plus 2 standard deviation, and 99.7 on 3 standard deviation. So here, it's very useful to find this number if we have the z-score. By the way, we are not going through the z-score here, but we have a video about z-score, and the video is in our video description. How do we do that on Excel? Normal distribution, with the number, our x, the mean, standard deviation, and cumulative. Cumulative through calculate the cumulative probability. False simply calculate the value of the density function, which has little practical application. However, very useful to chart the curve. So let's go to our file. So here, daily returns of two stock exchanges, NASDAQ in the US, Ibovespa in Brazil. So how do we do it? Let me delete the NASDAQ. So let's delete only one, because the other one will be a copy and paste. And also let's delete the chart. So, okay, we have the z-score, and the z-score is quite useful. How many data do we have on that three lines? So here, for instance, Ibovespa 57% between -1 and +1 standard deviation. And Ibovespa means that 66. So maybe Ibovespa is more normal than NASDAQ. And here the formula for the Z and so on. So let's go to the formula of NASDAQ. So we can go on formula, insert function, and all. Let's see if we have something here. Norm distribution. And what we have? The x, the number that we want to calculate. Mean, average, because we don't have it. And then all of our numbers here. And F4, we fix them. And the standard deviation is standard. Let's do it here. It's easier. Normal distribution. And why it's easier? Because you can insert a formula inside a formula. So x, the mean is the average. See? So the average F4. And the standard deviation is standard deviation population, because we are grabbing all of our numbers. And then, oops, missing parentheses, false. Oops, here missing one parenthesis, and now we're good. So this is the F. So it's not the cumulative. The cumulative is the same formula. So let's copy and paste the formula, not the cell. And instead of false, we go on through. So there is 79 or 80% of probability that NASDAQ will be from 0 to 15,382, for instance. And here, copy and paste. And okay. And here, probability of NASDAQ between these two numbers, between 15,500 and 15,300, it is the difference between these two numbers, so 2 point something percent. Okay? And how do we do the curve? How can we do the normal curve? Just like here on Ibovespa. We select the X and the FX, or the false. Whoops. Why is there a num here? Oh, the standard deviation is wrong. Oh, come on. Standard deviation, we need to fix here, to fix here. Now it's good. Fix here and fix here. That is a very common mistake, by the way. And now we are good. Okay. So how do we do the chart? We select the X and the FX. So the false. And we create a scatter plot. So scatter. And then here we have some different scatter plots, and we can choose any scatter plot that, any scatter plot that we want, because here it will be, and then we can go on this one. Here, smooth lines instead of the dots. So it looks more like a curve, much better than or on here on dots as well. So see, that is a normal distribution. But it's not that pretty and so on, because in real world, we hardly find a perfect normal distribution. Okay, so we usually go on these because we are taking partial numbers. We always take partial numbers. However, can we charge the cumulative distribution or not? Yes. However, what have I done here? So first of all, let me work with the raw data. Yes, so just like a copy and paste, here is not that pretty on Excel because I need to split it into NASDAQ and Ibovespa. Ibovespa is here, we will do it later. If we try to do it now, so we do with the cumulative. So let's chart the cumulative. We can go on columns or lines chart. Let's go on column. See how not pretty they are. There is not a cumulative function. So how do we fix it? We need to sort our NASDAQ. Our NASDAQ. So we cannot sort on date. We need to sort on our X from the lowest to the highest. So data, let's sort it here. Then it goes on a cumulative charge. Then it goes on a cumulative function just like any other distribution. And the same for Ibovespa. They are here, so also, okay, and now the F, oops, there you. And then here we can also go, instead of going on the column chart, we can go on this one, on lines. It is the same, or we can go, oops, sorry. So we can go here on column. So, oops. Hey, here, quite a normal curve too, right? Because, so not a scatter, because I was selecting the wrong one. So here, insert. So it goes on here. So completely up to you to choose which one you want. So this is a normal distribution. So for instance, here on the raw data, probability between, so let's find a place here. Probability for NASDAQ to be between 15,382 let's make it pretty, just like what you see. And by the way, guys, this Excel file is free. Between 15,382 and 16,773, for instance. So here it will be 15,382, this one, minus 16, this one here, 573. So here, oh, okay, the highest minus the lowest, right? So here, oh, come on, minus D2. So it is 15% of chance of NASDAQ between these two numbers. Or we can combine both F function here as well. So this is what we have. Or if we want to go to one formula, so for instance, probability between 15,000 and 17,000. I have no idea if we have these very rounded numbers. Probably not. So equal normal distribution. So first, the highest one, K11, and then the average of NASDAQ minus the standard deviation of the same NASDAQ and true. So this first normal distribution minus the second normal distribution. Normal distribution, now the lowest one, average. Or we can create a cell here with the average, then it will be faster to do that. The standard deviation of the same and true again. Let's see, what do we have wrong here? Whoops, here it is a comma. Now I think, yeah, so it is 25% of probability that NASDAQ will be between 15 and 17,000. If we go here between 16 and 20, it is 11%, and so on, because we never hit the 20. So, or between 10 and 15, 72%, and so on. So this is the normal distribution, and we can do the same for Ibovespa and so on. And if we have a cell with mean and or average and standard deviation, we don't need to add this formula for average and standard deviation. That's a matter of how many numbers will you want to add here. Okay, guys, normal distribution, I think, is the most important distribution that we have. So watch this video how many times you want and need. So thank you. Questions or comments, leave it here or email me at jscarpin@gmail.com. Have a very nice day and God bless you.